Welcome to Ask and Learn.
In this problem, we have a beam supported by a couple of springs. So a spring here and a spring here. So here's our rigid beam, and then there's a load out here acting in the vertical direction. So I'm actually gonna just say this is our origin, and so F1 is minus F in the vertical direction. F2 is F2y in the vertical direction, and it's at 1 meter from here. And F3 is minus 3y in the vertical direction, and is 3 meters from the origin. So we just have we have three forces to plug into our force and moment balance, and we can solve those in terms of F here. And we get that F3y is actually, we wind up with just two equations because we only have two unknowns, and the horizontal force balance is just winds up being 0 equals 0. So two equations, two unknowns, and we get F3y equals F over 2, and F2y is 3F over 2. But they wanted us to determine if their springs are originally unstretched, when the force is and the force is vertical, so determine the angle theta that the bar makes with the horizontal when this force is applied. So it's normally straight here, and the springs are unstretched. So we are told that each spring has a spring constant of 100 Newton per meter. So we can figure out the displacement at this point and this point. And then we can figure out the angle that this thing makes by taking the difference, just using our triangle here. And then this distance is 2 meters here. So we get the difference in the displacements at the 2 points divided by 2, and that would be the sine of the angle. So we take the arc sine of it. In fact, if we just plug in this thing, if we just plug in symbolically these values, we just get actually that this is F over K, because this is just works out that way. So we have inverse sine of that is 17.5 degrees. So it's bent down like this. So this actual point goes up. This one comes down.